First come first serve, FCFS, scheduling, algorithm. First come first serve is a non-preemptive scheduling algorithm that schedules processes based on their arrival time. The algorithm states that the process that requests the CPU first is allocated the CPU first. It is implemented by using the first in, first out queue. When the CPU is free, it is allocated to the process at the head of the queue. Here's a step-by-step explanation of how FCFS works. 1. Arrival of processes. As processes arrive, they are placed in a queue called the ready queue. 2. Execution order. The process at the front of the ready queue, the one that arrived first, is selected for execution. 3. Execution time. The selected process runs until it completes its execution or is blocked by an I/O operation. 4. Completion. Once a process finishes, the next process in the queue is selected for execution. 5. Waiting time. The waiting time for each process is the time it spends in the ready queue before getting the CPU. Advantages of FCFS. Simple and easy to understand. No starvation. All processes eventually get CPU time. It serves as a baseline for understanding more complex scheduling algorithms. Disadvantages of FCFS may result in poor turnaround time, especially if a long process arrives early, causing subsequent short processes to wait. Known as the convoy effect, where short processes get stuck behind a long process, leading to inefficient resource utilization. FCFS is typically used in scenarios where the order of arrival is considered fair and no particular priority or criteria influence the execution sequence. Example of FCFS scheduling algorithm. This table demonstrates 5 processes that have arrived at the CPU ready queue at the same or different times. The process with the minimal arrival time goes first. If 2 processes arrive at the same time as of our case, the process with the lower process ID is executed first. Since the first process A has a burst time of 2 units of time, the burst time is the amount of time a process requires to complete its execution. The CPU will remain busy for 2 units of time, which indicates that the second process, B, have to wait for 2 units of time since it arrived at the same time of the first process. Process B will be burst in 4 units of time, then process C that arrived at 3 units of time enters and takes place at the 6th unit of time to be burst in 1 unit of time, and the same goes for the rest of processes. So, the completion time for processes A is 2, B is 6, C is 7, D is 8, and E is 9. In this way, the waiting and turnaround times for all processes can be calculated. Turnaround time equals completion time minus arrival time. So the turnaround time for processes A is 2, B is 6, C is 4, D is 5, and E is 6. Waiting time equals turnaround time minus burst time. So the waiting time for processes A is 0, B is 2, C is 3, D is 4, and E is 5. The average turnaround time show 4.6 and the average waiting time 2.8 unit of time. We can contrast this with other algorithms for the same set of processes.